Welcome back to my next video, and this is chapter 2 of part 1, Introduction and Understanding of Pentacam from the Beginning. This chapter includes the discussion of pachymetry maps, thickness profiles, Bellin-Ambrosio enhanced ectasia display cert, and corneal tomography. Let's get started. Pachymetry maps. The pachymetry map has three main landmarks: cornea apex, sinus location, and two opposing points, superior and inferior, on the vertical meridian within central 5 mm circle. This map enables the characterization of the thickness profile of the cornea. The normal difference between superior and inferior points is equal or less than 30 microns. The difference between two eyes should be also less or equal than 30 microns. Corneal thickness represents an important variable when planning keratorefractive surgeries, evaluating ectatic diseases, and assessing corneal endothelial affection. Additionally, corneal thickness affects intraocular pressure measurements, and pachymetry may be an independent risk factor for glaucoma. Please note, the computer measures the thickness of the cornea at all points depending on the elevation maps. The difference between the front and back surface elevations is corneal thickness. This is a normal concentric shape of pachymetry map. Normal cornea is a negative meniscus lens, which is thin at its optical center. The normal pattern is usually circular, however this pattern can be encountered in keratoconus as well. Those are abnormal patterns. Dome shape. The thinnest location is vertically displaced. Please note the red arrow. This is a bell shape. There is a thin band in the inferior part of the cornea, and this is very characteristic for PMD, pellucid marginal degeneration. This is a horizontal displacement pattern. Please note the red arrow again, this arrow shows the horizontal displacement of the thinnest location. Keratoglobus, a generalized thinning reaching the limbus. This is also very characteristic for keratoglobus. And droplet pattern. In this table, you can see distribution of corneal pachymetry at the apex, pupil center, and thinnest point for a normal cornea. And this is a table of pachymetric asymmetry at the corneal apex, pupil center, and thinnest location. This data is based on the data from Bellin and Ambrosio. There are also some limitations of pachymetry map. Corneal opacities lead to artifacts. The area of scar is usually displaced as flat area. Scarred area are interpreted as thin, which is not always true. So this is flat area, and you can see in the image those blue areas. And in case of corneal scars, anterior ossity is more reliable. And as you can see on this image where I showed that it's not keratoconus, so this is a scarred area, which is most of the time being confused with keratoconus. The relative pachymetry map. In the relative pachymetry, the thickness map of the captured cornea is compared with a standard normative thickness map in normal population, and the relative pachymetry map is displayed as percentage values. And there are also some patterns where you can describe or evaluate the cornea as normal, suspicious cornea, and abnormal. Thickness profiles. When it comes to thickness profiles, we have to know the definition of CTSP, this is a corneal thickness spatial profile, and the percentage thickness increase, PTI. The CTSP describes the average progression of thickness starting from the thinnest location to corneal periphery in relation to zones concentric with the thinnest location. The PTI describes the percentage of progression of thickness starting from the thinnest location to corneal periphery in relation to zones concentric with the thinnest location. So basically, you might say now that the definition of both sounds a bit complicated, but what is the point that CTSP describes the average progression and PTI describes the percentage of progression. The original analysis for CTSP was performed using 22 circles centered on the thinnest point with increasing diameters at 0.4 mm steps. The pachymetry values along each circle are averaged and plotted to create the corneal thickness spatial profile graph. And this is how the normal graph or normal pattern looks like. The normal patterns of both CTSP and PTI is presented with a curved line plotted in red, following the course of the normative black dotted curves. The shape of the curve, as you can see, should show a gradual increment. The reference in this regard is the 6 mm zone, and this you can see with a red circle. If the curve deviates before 6 mm zone, then this considered as abnormal. The CTSP and PTI graphs provide information which allows the clinician to differentiate a normal thin cornea from one with early ectatic disease. Or, additionally, those graphs enable to detect early edema in which the change in thickness from the center towards the periphery is decreased. So, in this case, for example, in this image, you can see that PTI graph is flattened. And this flattening typically seen with early edema in the cornea. CTSP and PTI graphs comparing a cornea with normal thickness progression to one with abnormal thickness progression. And in case of abnormal thickness progression, you can see the interrupted red line before 6 mm zone. Ambrosia 2 color palette is also suggested for use on corneal thickness maps. This scale was designed to facilitate the differentiation of thin and thick corneas. This scale provides important information regarding the thickness profiles, which cutoff values for normal population, for keratoconic patients, and patients with endothelial dystrophy or corneas with edema. The distribution of the colors around the thickness points correlates well with pachymetric distribution graphs. The pachymetric progression index, PPI, is also a very important parameter. This parameter is calculated for all hemimeridian 360 degrees starting from the thinnest point, and the normal PPI average is 0.8 to 1.1. When this value average is less than 0.8, then cornea is thickened, and this means that cornea has an edema, and it can be a sign of cornea guttata or Fuchs endothelial dystrophy, for example. In case when this value is more or equal to 1.2, then the cornea is abnormal, and this is mostly by ectatic cornea we can see. Normal value should be less than 1.2 mm. Note that 7% of normal eyes have average PPI between 1.2 and 1.8. In addition, 10% of the cases with clinical keratoconus can be also with the value less than 1.2 and may have CTSP and PTI within the normal limits. Let's continue with abnormal patterns of thickness profiles. So this is a quick slope. Why it's called quick? Because the red line changed its direction before 6 mm zone. As you can see, it's pointed with red arrow. And the average here is 1.5, which is more than 1.2, and this can be an ectatic cornea, for example. The flat slope, an average here is 0.6, and this is a sign of edematous cornea. S-shape, the direction of the red line is also changed before 6 mm zone. The average is 2.9. An inverted slope, where we can see that the direction of red line is changed and directed above, and the average is 0.2. So in general, quick slope and S-shape are encountered in form fruus keratoconus and ectatic disorders. Flat slope is encountered in diseased, thickened or edematous corneas, as I said, and particularly can be in Fuchs dystrophy or cornea guttata. An inverted slope is encountered in some cases of pellucid marginal degeneration. Bellin-Ambrosi enhanced ectasia display cert. It consists of Bellin-Ambrosio ectasia display, elevation-based pachymetry, and pachymetric data and numeric values. Here we will start with enhanced reference surface. The concept behind this is to devise a reference surface which will further magnify any existing pathology. Enhanced reference surface identifies a 4 mm optical zone centered on the thinnest portion of the cornea. You can call it also a new enhanced best fit sphere, which I discussed in the first chapter of part 1 presentation. As we know, best fit sphere should be evaluated in a diameter of 8 mm, and in this case, enhanced best fit sphere evaluates the cornea at the thinnest point within 4 mm diameter. Because the normal cornea is only minimally prolate, the resultant enhanced BFS in normal eyes has almost no difference in the elevation maps using the standard versus the enhanced best fit sphere. This is the next sample where you can see that the enhanced reference surface with the normal best fit sphere surface actually doesn't have a big difference. Excluding the 4 mm zone from the best fit sphere in this normal eye has little effect on the best fit sphere computation. The elevation maps using the standard best fit sphere and the enhanced best fit sphere will look remarkably similar. As you can see that those images on the right and the left, they look almost the same. Enhanced reference surface of posterior elevation map of a conical cornea. In this case, excluding the 4 mm zone from the best fit sphere calculation eliminates the cone or steep portion and results in a significantly flatter best fit sphere. For example, here, best fit sphere 8 mm shows this flat cone, and best fit sphere of 4 mm shows a real cone. Let's continue with some samples. So this is a normal eye. This is a best fit sphere. The two images above of best fit sphere of front and back. Enhanced best fit sphere, also front and back, within 4 mm diameter, and difference map. And you can see all those images are green. So this is a normal sample. And what is also important that this is a valid data, where you can see that the diameter of best fit sphere is 8 mm. And the image on the right shows that this is a less valid data with the diameter which is not 8 mm. So here, let's continue with this bottom display. This is a simply mathematical difference and does not convey shape information, but based on that you can just know the values. In this bottom display, the green areas on the front should be less than 5 micron and on the back surface 12 micron. Less than 20 micron. The red areas, they're encountered for the areas on the surface more or equal to 7 micron, and on the posterior surface more or equal to 16 micron. And yellow areas, they're on the front surface 5 to 7 microns, and on the back surface between 12 and 16 microns. So normally it should be colored in green. So this, when it's green, then you know that this is normal. In suspicious eyes, then you will have a yellow area, and in ectatic disease, you will have a clear red area or island. We will continue now with a few clinical samples. For example, here, a patient with early keratoconus. The baseline elevation maps show the presence of a mild cone limited to the posterior cornea. So here, for example, on the left side, and this is anterior, you can see no cone, but on the right side of this image, you can see a mild cone. So this area is red, which is encountered for ectatic changes of the cornea. So this is abnormal cone. And you can see that the red area on the center, which is encountered to the value more than 20 micron. And on the front part, everything is only green. So this is a suspicious posterior elevation map. In this case, for example, again, on the anterior surface, you don't see any changes. Everything is green and beautiful, where on the back surface, you can see this yellow island, this yellow suspicious flag. So in this case, you might suspect of forme fruste keratoconus or the cornea with ectatic changes. Here I will continue with pachymetric data, which is being used additional to the information from pachymetric map. So let's start with progression indexes in this square. So here those parameters are minimum progression index defines the half meridian with smallest progression index, and it's displayed in green. Maximum defines the half meridian with the largest progression index displayed in blue. Average, it's the average ratio of individual progression to normative progression. And Ambrosio relational thickness, the ratio of the thinnest corneal thickness to the pachymetric progression index maximum. There are also those deviation parameters, which you can see on the bottom. DF, or we can also call it D values. So DF is the deviation of front elevation difference map, DB deviation of back elevation difference map, dP deviation of average pachymetric progression, dt deviation of minimum thickness, dA deviation of IRT maximum, and the final D is the total deviation value. So of course clinically is important as the last D to evaluate, and normal value is less than 1.45. And in this table the data summary from receiver operating characteristic curves of pachymetric parameters in normal and keratoconic eyes. And here you can see those cutoff values for RT maximum, average, and PPI average and minimum. So we continue with the next slide. This is a clinical samples. This is a one patient with two eyes of ectatic disorders. So right eye represents a typical keratoconic cornea. Here we can see the IRT maximum is less than 360, which is abnormal, and D value is 7.89, so it's many times more than 1.45, which is a normal value. And on the left eye of this patient, IRT maximum is less than 412, which is also considered to be abnormal, and D value is 2.06. So in this case, D value is not that extremely high compared to right eye, and it's encountered to forme fruste keratoconus. Corneal topometry. When we talk about corneal topometry, then we describe basically the corneal asphericity. Corneal topometry measures the slope of the cornea on anterior tangential map. There are four main patterns of corneal asphericity: spheric, aspheric oblate, aspheric prolate, and aspheric hyperprolate. To give the slope of the cornea a value, Q value was calculated. The normal value is between minus 0.80 to 0.40. Q value can be positive, negative, or equal to 0. Q value is positive, which means more than 0, when the cornea is oblate. Negative, which means from 0 till minus 1, when the cornea is prolate or hyperprolate. And when the cornea is spheric, Q value is equal to 0. In keratoconic corneas, Q value is highly negative, and after high myopic photoablation, Q value is positive. Abnormal Q value causes spherical aberration, and the least spherical aberrations are found when Q value is equal to minus 0.27. So this is already a fixed amount of the value, and there is no spherical aberration when Q value is equal to minus 0.53. Let's continue with a corneal asphericity on the curvature maps. So this is how on the curvature maps looks spherical cornea, oblate cornea, and prolate cornea. This is a corneal asphericity on the elevation maps for spherical cornea, prolate or hyperprolate cornea, and oblate cornea has this image. Here you can see samples of corneal asymmetry on the curvature maps, normal corneal asymmetry, asymmetry in ectatic cornea, and conic pattern in ECD, which is ectatic corneal diseases. And all those patterns actually were more detailed described in the first chapter of this presentation. Here, corneal asymmetry on the elevation maps, horizontal corneal asymmetry in normal cornea, ECD tongue-like extension, and ECD segmentary asymmetry. There are 7 topometric indices: index of surface variance, index of vertical asymmetry, keratoconus index, center keratoconus index, index of height asymmetry, index of height decentration, and radius minimum. Measured values are compared with the means of normal population. Values which exceed the standard deviation more than 2.5 times are abnormal and highlighted in yellow. This you can see at any suspicious cornea or corneas with some beginning ectatic changes. Those which exceed the standard deviation more than 3 times are pathological and highlighted in red. In general, in the clinical practice for ectatic disorders progression, the documentation of 2 values are being used most, and those are index of surface variance, ESV, and the index of height decentration, EHD. And I also would like to add that abnormal and pathological values of each of those indexes are also presented in this slide and in the slide above. This was the second chapter of Introduction and Understanding of the presentation pentagram from the beginning. Hope you all enjoyed it. Thank you for watching. Till the next time, and don't forget, stay positive, stay healthy.